Hello everyone, welcome back to the channel. Now in this video we are going to implement another searching algorithm, that is ternary search. Okay, in this one we call it ternary search because instead of searching for two sections of the array, first half and second half, we have three different sections. Okay, instead of having one mid as we used to have in binary search, here we are going to have two mid 1 and mid 2. But still, although I am telling you about this searching algorithm, still if you do a bit good comparison, binary search is still the best algorithm, and that's all you need to solve the actual problems. Okay, but still, for the knowledge sake, we are going to learn few more searching algorithms, and one of them is ternary search. We are going to implement this again using recursive approach. Let's have ternary search numbers, number to search, 0 is the first index, numbers dot length minus 1 as the last index. Let's create that method. Now let's name this correctly, start and end. Okay, now what we're supposed to do, we can write a base condition right away. We can do this in the end as well, but let's write it right away. If start is greater than end, return false. Okay, now what we need a partition size. In ternary search we have something called as partition size. We have to calculate it, and then only we can make sure our start and end pointers are at correct position. Okay, let's calculate that partition size. Now the best way to calculate partition size is end minus start, and minus start divided by 3. Now let's calculate our mid 1 and mid 2. How do we do that? Int mid 1 is equal to start plus partition size, and int mid 2 is equal to end minus partition size. Okay, now let's start with the comparison. If numbers of mid 1 is equal to number to search, or numbers of mid 2 is equal to the number that we are looking for, return true. Perfect. Now if the number that you're looking for, okay, is less than numbers of mid numbers of mid 1, in this case what are the pointers that you're going to change? Ternary search numbers, number to search, start will remain the same, end will change, that will become mid 1 minus 1. Okay, now if number to search is greater than numbers of mid 2, then you're supposed to update the start pointer. Mid will remain, end will remain the same, numbers, number to search, start will become mid 2 plus 1, and this will remain as end. If it is not there in the first half, it is not there in the last half, not half, I'm talking in terms of half. Okay, if it is not present in the first section, it is not present in the last section, then it must be there in the middle section. Now how do you write condition for that? Else return ternary search numbers, number to search, this would be mid 1 plus 1, and this would be mid 2 minus 1. And I think we are done. I know there might be chance of getting confused a little bit there, but don't worry. If you just do a small dry run for this one, okay, you can easily find how the logic is working. So instead in binary search you had one condition to check. You have one mid basically through which you are checking if it's before mid or after mid, right? Similarly here are two mid, and you're not calculating that middle with the start plus n divided by 2 with that logic. Here you have something called as partition size. You are calculating the partition size, and you are calculating your mid 1 and mid 2 accordingly. And that's the logic for ternary search. Let's try executing our program and see if the logic we have written is correct. I think we are written, okay, we are writing 2, it's correct. You can do the whole dry run as well. You are more than welcome to do that. Let's try running with the incorrect value, which is not there in the array. We're supposed to get false, and we are getting false. So you have seen that ternary search is not that much complex, but we are doing a lot of conditional checks there, okay, which I'm not even sure which is even required, okay. But that's how that's what algorithm is. Based on the use case we choose the algorithm. So this is how you implement ternary search. That's all as part of this video. See you in the next one with some another searching algorithm. May the source be with you.